This is the latest addition to the workshop. This is a high voltage power supply made by Keithley Model 240A. I was looking for a high voltage power supply. I have got the Pharmacia 300 volt power supply, but unfortunately it only goes up to 300 volts, and most of the time that's fine for valve stuff. You don't need any more than that, but I just thought it'd be nice to find something that probably goes a bit higher. So I was doing searching, not particularly seriously looking for anything, and I came across this Keithley. This is a 1970s probably supply. You've got a variable range from 1 volt up to 1200 volts or 1.2 kV. It's quite unusual actually, because it's got an output through a PL259 RF socket, which is a bit unusual. But it's in good condition, and the seller demonstrated it working. So I thought, well, I'll make an offer. It was a buy it now or best offer. I'll make an offer on it, and he accepted my offer. It's turned up this afternoon, and thankfully this one turned up in nice nick. Was wrapped well and was transported by UPS rather than my herpes. So the thing turned up in pretty good condition. So this evening we're just going to have a quick look to see what it's like inside, because the plan will be to recap it. I think it's deserves a recap. I managed to find the circuit diagram online and the manuals, so it's not going to be difficult to source parts or source manuals or anything like that. So let me just run through quickly. I think most of you will know, most of my followers will know exactly how this thing works. Basically, this is a high accuracy power supply. I think it's within about 0.1% of its output, probably better than that actually. I'll have to check the specs. So basically, power switches here. These are the output terminals. You can use it as the center connection, which is the positive, or it's not actually the positive. You can select if that's positive or negative, but this switch here selects if the center terminal is positive or negative, or the output is off. There's a switch, a knob here, so like a volume pot and an on and off switch like on the old radios. So in the position where it's off, it's in calibration mode, and you're relying on these scales to give you an accurate reading. If you want to fine tune the adjustment, you can adjust it with the pot. This is a ground connection here as well, so you can use a connector in there, a banana connector in here, and a banana connector in here, and you've got flying leads as a conventional output. Maximum current capability is around 10 milliamps. I think the manual suggests you can get a little bit more than that out of it, but the performance degrades. It uses 3 valves and the rest of its transistors, and I know a lot of people wonder why they're using valves and transistors. Well, basically because it's working at such high voltage, transistors are not reliable at that voltage. I don't think there are any transistors even now that are capable of working at that sort of voltage. I know things like the BU208s and things like that in the flybacks of TVs used to be pretty high voltage, but this is using a valve for the output and the regulation, and it's using 2 discharge lamps which are regulators. I don't know if you've seen those before. We'll show those working in a moment, and they're basically a voltage reference to give a stable referenced output. So that's basically what it is. So it's straightforward enough. If you want 250 volts, you turn that to 2, you turn that to 5, and that should be giving you 250 volts out with that connection on the positive. That will give you a positive 250 volts out. That will give you a negative 250 volts out. It's as simple as that. It's very straightforward. But as I say, because it's probably 45, 50 years old, we'll have a look inside so we can find any date codes. I want to recap it. I think it's worth recapping, something like this. It hasn't got a lot of parts in it. The parts are easy to get hold of. I think it's got a couple of 22 microfarads, 450 volt, and I think it's got a couple of slightly higher volt. I think they're 40 microfarad at 350 volts. So I put in sort of a couple of I can replace with 47 microfarads at 450 volts. I've got some of those actually, some good quality ones that were off a scrap unit at work that went for recycling, and the capacitors had never been used. So I've saved those. So I think the next part is I'll just cut to taking the lid off it, and then we'll have a look inside and see what we've got. Okay, here's the inside, and basically this is just a power supply, simple as that. We've got 6 reservoir capacitors here and 2 here. This is the output valve that does the sort of like the regulation and everything, and these are the 2 discharge tubes or valves that I was telling you about that actually set the reference voltage, and I'll show you that on the circuit diagram in a minute. So the plan is to replace these 6 capacitors. I'm not sure I'm going to re-sleeve them in these cardboard tubes. I don't know what make capacitors these are. I'd expect with Keithley them to be reasonably good quality capacitors, but there's no names on them or anything. But we'll get those out and have a look. We've got this capacitor down the back here, this black cat, which sounds a bit ominous. So that is that's a non-electrolytic that will probably be replaced as well. I'll get you a place where you can see it best. So it's like a bit like one of those black bumble things that Shango 066 always goes on about. So that's a capacitor that will probably need checking to make sure it's not leaky. It'll probably be fine, but we'll just check. It's a 0.033, so it's a 330 nan, and it's probably about 1.5 kV the size of the bloody thing. So we need to find another capacitor that's a suitable replacement. What we've got up here, so yeah, you can see one of the regulator valves here. There's 2 types of regulator valve for different voltages. I've got a polystyrene capacitor. You probably can't see that. There it is. It's just between the capacitor on the left and there. So that polystyrene capacitor will be fine. They never go wrong. You've got a couple of high voltage diodes, and these look like sort of like these things with a screw on the end, are like a resistor, probably sort of like for current monitoring, something like that. I'm not entirely sure. Current limiting maybe. You've got a couple more diodes down the side there that you can see. But basically, it's in lovely condition. And when I took the top off it, it still had the integrity screws in. So it's the integrity seals. Sorry. So this is all the selection area here, and this is where all the sort of like the voltage references are sort of ascertained. You've got some sort of old-fashioned sort of diodes down here. These 2 diodes. You see these 2 diodes, and then we've got 3 potentiometers, and they're very straightforward and very easy to set. Basically, what you do is you set it to say like the 100 volts range, and you adjust this calibration pot here for 100 volts. Once the unit's properly warmed up with the lid on it, you must have the lid on it so it sort of thermally stabilizes. Then you set the output to 0 and adjust that 0 control, and then just ascertain that the voltage is still correct. And that resistor up there, we shouldn't need to adjust that. That basically sets our current limit, and that should activate the current limit light at 10 milliamps. And you wouldn't want to go much more than that, though apparently the valve is capable of sinking 100 milliamps for a short period. I wouldn't really want to trust it. I think it would be a bit of a long time to overload that valve. So here are our selector switches, and I want to clean these up and put some service or contact cleaner in, but they all work fine. They're a little bit clunky. I would like to see if I can make them feel a little bit nicer, you know, a little bit more tactile to the turn, and that might be just a bit of lubrication. That's all they need. There's another one of those black bumble things or whatever they call them down the back there. You see that capacitor right down the back? There you go. It's lit up with this orange writing, and that's, I can't see any date codes on any of these, but there's another big bugger down there. It looks like that's possibly on the output, but that's a big old capacitor. That big old that's a polyester or what that is, but it's certainly a big capacitor. Now these caps are probably fine. I'm not too bothered about replacing them unless they're definitely failing. And the one way I'll probably test these is just to unsolder one end, and there's the other one that we've just looked at, the black cat. Disconnect one end and apply whatever the voltage rating is. What's that? 1600 volts that capacitor rated at. So I'll use my mega and apply 1000 volts to it and see if it's got any leakage. That's where those isolation testers are really good for checking capacitors like that. Or we could put it on the solar capacitor checker. So the first thing to do is, I think I'll take the base off it. I'll get some of these capacitors out. We'll check the values of these and see what they're like. But I'm going to replace them anyway. But I'd be intrigued to see if they've still held their capacitance. Because they're cardboard, I'm wondering if they sort of dry out quicker because they're not sort of hermetically sealed. But it looks clean inside. Let's get a couple of these capacitors out and let's see what we've got. Okay, got the LCR meter connected up to one of the capacitors. I've disconnected one of the leads just to measure the capacitance. And when I checked it at 1 kilohertz, it appeared reasonably good. I wasn't too worried about it, but then I compared it with another capacitor of similar value at the same voltage, and it was the dissipation factor, or the sort of like the equivalent to a ESR, was pretty high. Now these capacitors are 20 microfarad at 450 volts. Let me just show you what the meter's showing on the up there. So the LCR meter. Sorry about all the swinging around, but it's a bit awkward to set up otherwise. So there's our LCR meter showing 19.4 microfarad, which is fine, but that's at 1 kilohertz. And obviously these capacitors are working at 50 hertz. So if we drop it down to 120 hertz, the meter struggles a little bit to sort of find a range, which is a classic sign with this particular meter that the capacitors had it. Let me just try and lock it in a range so you can actually get a better reading at low frequency. It's as I say, it's a little bit pernickety. So range hold. No, it's not going to do it. So I think these capacitors are pretty dried up. We could check it on another capacitance meter as well, but if I check the capacitor I'm going to replace it with, and this is the capacitor I'm planning to replace it with. This is actually a 47 at 450 volts DC, and as I say, these capacitors have been used, but they're perfect condition. They were the actual piece of equipment that we were working on caught fire, and these capacitors survived, so I saved those. I thought they might be useful, and sure enough, they looks like they're about to be. So I'm going to try and get the capacitors off the board. Let me just show you underneath. This is going to be handheld, but let's get these clips out of the way so you can see. So these are 3 here, and there's another 3 here behind, and this transformer here behind here. So those are the 3 that we're going to start off with. Get those off the board and then try and replace them with something a bit more modern, and we'll once we've done that, we'll move on to the next one. So now the next 2 I think are 47 mics. I'm just looking at the circuit now. This is the circuit, by the way, and you can see how well you can see it. It's the power supply section here. This is all the programming part. Here's our output valve. This is the dropper section for the switches, and their output terminals here. So this is where all the calibration and adjustments are done. This is the sort of basically the raw high voltage section here. Here are our discharge tubes here, voltage regulators. Those two valves I showed you here and here. So one produces 150 volts and one produces 107. I think there's an OA8 and an OB8 or something like that. This is our output valve here, as you can see, and that's producing our output. And it's sort of like a voltage reference here, so it looks fairly sort of like a standard voltage regulator. It's a long tail pair here. Basically, it's a normal sort of power supply sort of section. These will all be precision pots here, resistors here. This is our trim control, that's the one on the front panel. And just here is our calibration for setting our actual voltage to make sure that everything reads correctly. Now that will obviously only adjust the center trim. Each one of these ranges can be different. It depends on how accurate these resistors all are in the chain. They should be fairly good. And if you wanted to go totally overboard with something like this, which I'm not going to do, you could put sort of like turn these all into sort of like precision pots or presets, and you could get the voltage exactly right. But at the end of the day, it's a valve operated set. It's going to drift a bit with temperature anyway. So yeah, and there's another pot here. Where are we? This is our zero adjustment for setting our zero when all the controls are set to 0. You shouldn't be going negative or positive. That's the adjustment there. So let's get those caps off and start replacing those. Okay, as you can see, I replaced those electrolytics. They did actually seem to be pretty sort of weak, actually. I've also replaced these 2 here that I said I was going to do. These are 40 microfarad at 450 volt, and they tested okay, the old ones, but I've replaced these. These are 47 at 450, same as these. They're just a different manufacturer. So they're in. They don't fit exactly the same as, because the board was obviously designed for the sort of like the like the cleats on this and the end of the capacitor. This is a different mounting, but they've gone in okay, and I've connected them up. So these are all in series. These and the resistors that I've showed you earlier on. These resistors here, these 470Ks. Yep, 470Ks. Basically, make the capacitors share, or help the capacitors share. So if one gets a bit lazy, it sort of helps the other one pass current. Basically, that's all it does. So those two are in. These two are in. What I'm going to do once I've ascertained things working okay, and it's happy with this increase in capacitance here, which it should be. I'm going to mastic them in with some proper sort of Celestic stuff that we use at work. RTV it's called, which is a like a silicon based stuff, but it hasn't got the is it citric acid in it, so it doesn't damage the board. So basically that's the power supply recapped really. That capacitor appears to be okay, and likewise I think the one down on the front panel is okay. So the next stage I'll do is just give this valve a bit of a clean up, only for sort of cosmetic reasons really. It's in a fairly good state. We'll power it up, and then we'll have a look to see how it performs. This is the underneath. I'll just show you what I've done. So obviously this is where the one capacitor would go, so we had 3 complete sort of connections there. I don't know what you call these things, you know, there's like the fold off bits that go on the end of the capacitor, like a tab that bends over, tabs I suppose. That's connected to there, that's your positive and that's your negative, so that's in series of the next one, and that's in series of the last one. Oh, sorry about that interruption. My brother-in-law didn't realise I was videoing. Okay, so yeah, basically we've got it all connected up. It just needs a bit of tidying up. I'm going to clean the connections up with isopropyl. I'll get the flux off, a bit of glue support underneath as well. Just tidy the connections up. There's a bit of a jagged sort of connection here, so it looks like it's going to work fine like this. I know the switches and things. Now the switches all look okay. I'm going to run all contact cleaning through. I have noticed one of these switches here. See this one? Actually, you can see that it's moving a bit, so that needs tightening up. This is a lead that runs the high tension, or the output, from the front to the rear, so you can have a rear takeoff if you want, which is quite a nice idea. Very basic thing really, but I think it's going to be fine. So I think the next stage is to power it up, let it warm up, and see what it does for output. Alright, it's powered up and let it warm up. Okay, you can see that the this isn't the orange glow you see in this valve here, isn't actually the heater. That is the it's like a neon discharge. It's a discharge tube basically for regulation, and I don't know if you can see the one at the back's just struck up as well. That took a little bit longer to come up, so better check our capacitors around the right way, but I'm pretty sure they are. It's now making output, and we'll let it settle in for a while, make sure it doesn't do anything horrible, make sure the transformer doesn't get hot, blow a fuse or anything. There's no reason why it shouldn't. These are new capacitors. It's got a better chance of working now, despite me working on it, than it had before. So let's let it warm up and give it. I don't know. We'll give it. Probably doesn't need that long actually, really, because there's no sort of temperature related stuff here. Really, as long as this is all at ambient temperature, it should be fine. So give it 5-10 minutes to warm up, and we'll have a look at the outputs and see what it's like. That's the front panels. As you can see, it's got a typical sort of like a neon bulb, and this I think is also a neon bulb that comes on when it's in overcurrent condition. So we're presently set at 10 volts. If you short that out, we should get an overcurrent light. Come on, there we go. See? So yeah, that's working fine. We'll be checking all that to make sure that if the current limit circuit is set at the right level. But let's warm up and we'll come back. Okay, so this is the first calibration. It's very straightforward, this. So the Keithley is set to the output control at the bottom right hand corner is set to positive. The trim adjustment is set to calibration mode. The outputs are set to 0, so all the 3 controls at the top are set to 0. I'm going to adjust the 0 pot trimmer for 0 output. It's got a screwdriver that actually fits. It's got a big screwdriver slot. Okay, I'm going to bring it down to 0. Okay, it is out. A bit jumpy. pretty good. Okay, 0. That's as 0 as you're going to get, 0. And I think what we'll do then is we'll set it to 10 volts. And you see this is 9.9888. I'm adjusting now the calibration pot for 10 volts. Actually, what I'm going to do is this pot seems a little bit noisy, so I'm just going to squirt some contact cleaner on the control. Give it a bit of a wriggle. It sounds like it's a wire wound, so it should clean up quite nicely. Okay, here we go. So set it to 10 volts. Yes, pot is a little bit twitchy. Okay, I'm just going to work this pot a bit more. Try again. Very jumpy. Okay. 9.9987, let's just check our 0 again. Okay, our 0's gone a bit negative, so I'm going to bring the 0 back again. Pretty good. Okay, it's all back together. All the caps have been replaced. I'm going to glue them tomorrow. I'm not going to do it now. I haven't got the glue here. So let's just run through this and see if it was working sort of how we expected. Now I'm using the Fluke 75 this evening because the Agilent 34401 is more an accurate meter and it's got a high resolution, but it's a pain to sort of demonstrate it on the video. So let's just run it through now and just see how it works. So let's select a voltage. Let's start with say 1 volt. That's the right range for a start. And there we go, 1 volt on the meter, spot on. These flukes are extremely accurate actually, particularly on the volt range. They're you know, there's only one adjustment in these flukes, but if you get it right, you can more or less guarantee these meters are spot on. So that's 1 volt, so that looks good. Let's try it at 5 volts. 4.98, pretty good. Let's try it at 10. Let's try it at 50. Pretty good. 100. Good. 400. Yeah. 600. 599. That's okay. 800. 800 volts. Looking good. So that looks working fine. We'll try it in the reverse. Check the reverse switch works correctly. So we got 9.9 volts, and that should be minus 9.9 volts, which it is. That's good. That should be off. Yep. And then, so if we set to 9.9 volts, this should drop us back 1.5 volts. Sorry, the connections aren't that great. 9.9 volts. So we're down to, oh, that's plus, yeah. So that's plus 1.5 volts, so 11.5 volts, yeah, more or less. So that's the trim control. That seems to be working correctly as well. So it looks fine. We'll check our current limit to make sure that's right. Now, if you're new to this, you never apply, you never put an ammeter directly across a supply unless you know it has a limited current. And I know that this is a limited current. So what I'm doing is measuring the short circuit current of this output. So I'm going to the amp meter range, I'm going to DC amps, and then you see the lights come on the power supply. You can see it's red neon, and we're at 10 milliamps, which is what it's meant to be. So yeah, that's another power supply repaired, a bit of restoration on it. It's should be a nice meter, a power supply for testing valve amplifiers and things like that. It's got limited current capability, but it's good for that. The fact that you could actually power up an amplifier and check that there's anything wrong before you actually apply full HT for it. If you've got something like maybe shorty capacitors or things, you can power them up with this, and you can monitor the series current just to make sure that nothing's drawing excess current. it's in good condition, and it's obviously doesn't have, these sort of things don't get an awful lot of use, I wouldn't have thought, but it's in certainly nice condition. I put a couple of warning labels on it, as you can see here. Got this high voltage warning label here, and I put one on the top, really for my own sort of benefit, in case I get a bit blasé with it, and so I just plug it in and sort of get an electric shock of it, because it's capable of producing 10 milliamps at a 1 kV or 1200 volts could be fatal, probably. I wouldn't want to try it, so I don't know, but I'm certainly not going to experiment with it. So that's the Keithley 240A high voltage power supply. Thanks for watching, more to come.